Lesson 5-4, Indirect Proof. Don't be scared by the word proof in this section. It's nothing like the type of proofs that we've been doing. Think about this. If I want to prove that this is a mechanical pencil, one way to prove it is by trying to prove that it is not a mechanical pencil. You're going to be thinking opposites in this section. So there's 3 main steps to go about doing this. Step 1, identify the conclusion. Remember, that's the statement after the then or the second part of a hypothesis. We're going to try to prove it opposite. So if it says that something is, we are going to say that it is not. Step 2, use logical reasoning. That could be either an equation, it could be a theorem, a proof, a definition, whatever, to show that this is a contradiction. Okay? And lastly, we're going to point out that, hey, it's not true. And we're going to say that because our assumption is false, that it leads to a contradiction, the original conclusion that we made must be false. Now, what all that means, since that's a lot of words to try to wrap your mind around without an example, is this. We're going to start off with this. State the assumption necessary to write an indirect proof. So remember, step 1, we want to prove the opposite. So what is the opposite of EF not being a perpendicular bisector? Well, the opposite of not is that it is. So our statement that we would want to say is, oh, well, I say EF is a perpendicular bisector. That's my statement that I'm making. I would then go on to prove that to be true. And if I can't, then hey, then it's not a perpendicular bisector. Second one, if 3x equals 4y plus 1, the opposite would be that it does not equal. 3x does not equal 4y plus 1. And the opposite of equals is doesn't equal. Third one, if B is the midpoint of LH and LH equals 26, then BH is congruent to LB. Here's where I have a whole statement, and I talked about identify the conclusion. This part right here, the then part, that's my conclusion. Step 1 said to try to prove it opposite. So the opposite of it being congruent is it not being congruent. BH is not congruent to LB. Okay, number 4, example 2. We're going to write an indirect proof to show that if negative 2x plus 11 is less than 7, then x is greater than 2. So remember, we talked about identify the conclusion. This right here, that's my conclusion. So I want to then assume the opposite. So what am I assuming? Well, if x is greater than 2, I want to assume x is less than or equal to 2. Okay, how can I prove that? Well, I have an algebraic equation, so let's make x less than or equal to 2. So how about 2, 1, 0, and negative 1? Okay, what I want to know is if I plug x into here, it's going to be less than 7. So I need to plug it in. Plug in 2 for x, and you get 7. Plug in 1, you get 9. Plug in 0, 11. Plug in -1, 13. Are these less than 7? No. This is equal to 7, but there's no line, so sorry, not less than. So my assumption that x is less than 2, does it make it true? No, it made it false. All of these values are bigger or equal to 7, and that's not what I said. So because I am wrong, therefore x must be greater than 2. Because this is wrong, what I stated in the beginning must be true. So we're going to write that out to finish off our proof. The assumption x is less than or equal to 2 leads to a contradiction. Because it does, or therefore, x is greater than 2 is true. Example 3. Oops. Okay, in this example, you are wanting to find out how each class can cost less than $47. Okay? You want to prove it by contradiction. So we're going to set up a proof. So what are you given? What are you told that's true? You're told that Martha spent less than $156. That's a true fact. What are you trying to prove? You're trying to prove that each class costs less than $47. So we want to know that at least one class we're going to call that class X, cost less than $47. Okay, if I were to set up an equation, because I do have an administration fee of $15, that's regardless of how many classes I take, and I do know that each class costs the same, okay? So I want to come up with an equation. My equation is going to be this: 3x, 3 classes, plus the $15 administration fee. It says that she spent less than $156. Okay? What I want to assume then is that there was one class that cost more than $47, because here I say that it costs less. So my assumption is that X is going to cost more than $47. How can I prove that? Well, if each class costs the same, The easiest way is to say, what if they all were $47? So 47, 3 classes, plus the administration fee has to be greater than or equal to $156. If you solve that, you get 156 is greater than 156. That contradicts what we said, because the statement we said was that she spent less than 156. Here, she spent exactly 156, so that's not true. So now our last statement is we need to state that in words. This contradicts the statement that the total cost was less than, that was part of our given, 156. Since it contradicts it, our assumption is false. Which means that our class must cost less than $47. When you're wording it, if you don't word it word for word like I did, it's okay, as long as you have in there that it contradicts the statement and that your assumption is false and what must be true. Those are the 3 key ingredients to a good proof. Next example. Write an indirect proof to show that x is a prime number not equal to 3. Then x over 3 is not an integer. So first thing is identify the conclusion right here. What are we going to assume? We're going to assume the opposite, that x over 3 is an integer, which, if you forgot, is a positive or negative whole number. Step number 2 is we need to come up with logical reasoning. Since I'm talking about an equation, x over 3 has to equal a number. Well, what will x equal? If I solve for x, x is 3 times a number. If x is 3 times a number, can x be prime? Nope. So therefore, this contradicts our statement that x is prime. Be sure to state why. It contradicts it because n, our number, is divisible by x, and our number cannot equal 1, because 1 is not a prime number, since x cannot equal 3. Because of that, or therefore, x is not an integer, which is what we wanted to prove. Okay, last page. And I forgot to label your triangle on your notes, so make sure you copy it down. J is over here in the corner, K is up top, L is on the right hand side, JK is 8, KL is 5, and JL is 7. We are given that triangle JKL has side lengths 5, 7, and 8. We want to prove that the measure of angle K is less than the measure of angle L. So, step 1 is make an assumption. Assume the opposite. We want to prove that it's less than, so let's assume that it's greater than. Assume the measure of angle K is greater than or equal to the measure of angle L. Step 2 is use logical reasoning. So I'm talking about angle K and angle L. Last 2 sections we talked about angle side relationships. So if I look at my sides, L corresponds to the side that's marked 8. K corresponds to the side marked 7. So that is called angle side relationships. By angle side relations, JL is what? We want it to be bigger, but it's not. JL is smaller than JK. Well, this contradicts what we assumed. So, again, we have to state that. Number 3. This contradicts our assumption that the measure of angle K is greater than or equal to the measure of angle L. Therefore, the measure of angle K has to be smaller than the measure of angle L. The last one, I want you to try on your own. We're going to go over it in class. I'm going to start you off though. You're going to, first of all, correct my mistake in typo. And it should say the hypotenuse of a right triangle is the longest side. I accidentally typed not. First thing I would do is draw a diagram, because pictures are always helpful. I will start you off with the given, and that given is triangle ABC is a right triangle. I'm also going to tell you angle C is a right angle. What I want you to prove is that side AB is greater than side BC and AB is bigger than AC. That's going to contradict what I stated up here. You need to have, for me to check in class on Friday, your assumption, your statement, and then why it contradicts it.